Hi everyone, this is the second video for section 6.3 on multiplying and dividing fractions. So we ended the last video with a discussion of what it meant to do 1/2 times 1/3. And we said that that was finding a fractional piece of a part, where a fraction represents a part of a whole. So now we're going to kind of look at that using a model. So we are first going to draw a rectangle that represents one whole and find a third of it. So this is going to kind of mimic what we did up here in this example. So we're first going to find a rectangle that represents one whole and find a third of it. And this is what's shaded in blue. Sorry, these should be A, B, and C to match the A, B, and C up there. Okay, so we've drew a rectangle, find a third of it. Okay, so now we want to find half of the part we care about. So of this blue 1/3, right, to the blue 1/3 that's shaded, we want to find 1/2 of it. And that's what we did up here in step B in the purple. Let me write that. So this is 1/2 of 1/3, right? So that's the 1/2 of the 1/3. So the 1/3 was the blue rectangle, and then this purple is half of the blue rectangle, so it's half of a third. And then what we need to do is find the piece of the part. So find what size of, I shouldn't have written that here. So this is, sorry, half. So the purple is 1/2 of 1/3. And then we want to find out how much that represents in our picture as a whole. So we know that it's half of 1/3, but what we can do is we can extend this line right here that we used to make the half and see that we have 1, 2, 3, 4, 5, 6 total pieces. And that this purple piece that represents half of a third is 1/6 of it. So this is how we get this 1/6 right here, is because each of these is 1/6, and we have, well, we divided our rectangle into 6, and then one of them is shaded. So that's what we have here. And so this is how we use an area model to find a product. So we're going to do another example of this where we write everything out. So we're going to use an area model to find this product 2/3 times 2/5. Okay, so just like up here, the first thing is we're going to draw a rectangle that represents one whole. And we are going to find 2/3 of it, right? So the first number, so that's actually something important to notice. When we did this, we found 1/2. So this was 1/2 times 1/3 is 1/6. And so the first thing we did to do the problem, 1/2 times 1/3, is we drew a rectangle that represented 1/3 of the total piece, which is the second number. It's the second factor in our multiplication problem. So that is one thing to notice about the area model, is because we're finding a piece, we're finding a piece of a part. That means that we do the part first and then we find the piece of it. So the first thing we need to do is draw a rectangle and find, so the rectangle is going to be one whole, and find 2/5 of it, right? So 2/5 is the part that we start with. So we're going to find 2/5 of this. So I'm just going to do this. So we divided it into fifths, and we want to shade it to be 2/5. So I'm going to shade this in blue. And I'm going to make it a little bit bigger. Oh. So we're going to shade this in blue. It's not going to be that exact, but, you know, just for time. Okay, so there's 1/5 shaded, and now we're going to shade the second fifth. Okay, so we have 2/5 shaded. So we drew a rectangle and we found 2/5 of it. The second thing we need to do, right, just like up here, we need to find the piece of it. So we need to find 2/3 of the part we care about. So that's going to be the shaded part. So we're going to find 2/3 of the part we care about. and we're going to shade that like so. So if we divide our 2/5, we're going to divide it into 3 parts. So we're going to draw these lines here, and then we're going to shade it. We're going to find 2/3 of it. Nice. Okay, so we shaded 2/3 of it. And then the third step is to determine the size of the new piece. And so this new piece is going to be the part that's double shaded. Okay, so like before, it's going to be easiest if we just extend these lines all the way across. And so now, how many pieces do we have? Is we have now 15 total pieces. So we have 15 total pieces, and how many are double shaded? 4 of them. We have 4 that are double shaded. So we have 4 of these that are double shaded. Okay, so that tells us that we're going to have 2/3 times 2/5 is going to be 4 out of 15. And that is because we have 4 pieces that were double shaded out of the 15 total. Okay, now let's see how this relates to the multiplication algorithm that we all know. So the multiplication algorithm that we all know is saying that if we want to multiply 2 fractions, we multiply the numerators, multiply the denominators. So we have this formula where A over B times C over D is A times C over B times D. So you just multiply straight across. And you can see that's exactly what we've done up here in this problem. And so how does this algorithm relate to our answer? So we can see that 3 times 5. So whenever we multiply the denominators, that represents the total pieces, or the total parts our whole has. So once we extend those lines across the, horizontally, 3 times 5 represents how many total parts our whole has once we extend that. And the 2 times 2, the numerator, represents the double shaded area. Another way that some people may think to do this is, so if instead of so another way people may want to do this is like so. So if we draw our hole just with five pieces first. Okay, let me fill it in. So if we draw our hole with 5 pieces, and then we shade 2 of them in that blue. So we shade 2 of them in that blue. Okay, so we found 2/5 of the piece. And then if we want to find 2/3 of this piece as well, we just divide it into thirds and then shade 2/3 of the piece. So we're going to shade these bottom 2. And here, the yellow represents 2/3 of the piece, and the blue represents 2/5 of the piece. And this overlap that formed this green type color, this is the 4/15, the product. So the blue represents 2/5. The yellow represents 2/3. And the green represents 4/15, which is the product of the 2. So you could also think about it this way, just shade 2/5 of the shape horizontally, 2/5 vertically, 2/3 horizontally, and then the overlap will be that product, is another way that people might want to think about this. And that this is how you can truly think of these pieces as double shaded if you shade both of the different regions in different colors. Okay, so this is how the area models relate to the algorithm. I chose to do the models before the algorithm because we all know how to multiply fractions. So I just wanted to talk about how that related to it pictorially first. Okay, so now that we have the general formula for multiplying fractions, we have all of the same properties. So like I said at the beginning of the first video, all of the algorithms and models and even the properties of multiplying with whole numbers that we talked about in chapter 3, all of those extend here. So we still have the commutative property, where it doesn't matter which order you multiply things in. We still have the associative property that says it doesn't matter how you associate your parentheses. And we also still have the multiplicative identity property that tells you that whenever time you multiply anything by 1, it stays the same. So these are the properties that we've had before. So these are all the same. And in the next video, we're going to talk about a new property and then use these properties to solve some problems. So that's all for this video.